Hey everybody, Mr. Covey here. This is section 8.4, and we are going to be building on what you've been talking about relating to similar triangles. Last section you did some proofs to prove triangles were similar, and now we're going to build on those proofs with another idea. So I just want you to listen to start here. You don't need to write anything down. So back when we did congruent triangles, we took two triangles and we proved them congruent using one of our triangle congruent shortcuts. And once we had that the triangles were congruent, we could then conclude that the corresponding parts were congruent. Remember, we called this CPCTC. It was only after you prove the triangles congruent that you then use CPCTC to say that any other parts that matched up were the same. Okay? So keeping that in mind, we're doing something very similar with similar triangles. So first we're going to prove triangles similar. Here are our shortcuts that you talked about last section: side, 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 angle, angle, side, angle, side. And after you've proved triangles similar, then you can conclude two different things. First, you can conclude that corresponding angles are congruent. And you can also conclude that corresponding sides are not necessarily congruent, but they are proportional. And we'll state clearly exactly what we mean there. Okay, so let's take a look at our first proof here. So we are given that angle X is congruent to angle ZBA. So those two red angles are congruent. And it wants us to conclude that AZ over AB equals ZY over XY. This conclusion here is exactly this idea that we're going to be talking about, which is it wants us to show that corresponding sides are proportional. It wants us to show that the ratio between these first two sides is equal to the ratio between those second two sides. In order to use this idea, we first need to prove two triangles similar before we can use this proportional side idea. So let's start our proof with two columns. I'm going to lay it out here. Okay, so that's our only given information, but one thing you should notice is that these two triangles have a shared angle. Specifically, angle Z is an angle in both that smaller and that larger triangle. So we're going to need to use reflexive property. Say angle Z is congruent to angle Z by reflexive. And now we have two angles in both of the triangles. So we can prove those two triangles similar using angle angle with steps 1 and 2. And let's be careful here that we are matching up the letters, the vertices, in the correct order. So let's say we wanted to say triangle ZAB is similar to triangle. So if we did ZAB, we'd have to do ZYX for the larger triangle. Okay? So now we prove the triangle similar. This last step is the new part. And it allows us to conclude what we're trying to prove, which is that AZ over AB is equal to ZY over XY. And the reason that we can set up this proportion is corresponding sides of similar triangles are proportional. Since the triangles are similar, the sides must be proportional. So this is that new reason there. One last thing to draw your attention to. Please note that the reason that we can set up this particular proportion relates back to what triangles we proved similar in step 3. So ZA and AB in that first triangle is equivalent to ZY and XY in that second triangle. So please be aware of that. Second problem here, not a proof. It's just asking us to show that AB and DE are parallel. So the way we're going to show this is by first showing that these two triangles are similar. Since we have all the sides, let's show that all the sides are proportional. So I'm going to go ahead and do that, and then I'll unpause. Okay? So this is our setup. This is what I want to try and show, that these ratios are proportional. Sub in my side lengths. I get 3 fractions. Again, I am trying to check if these are equivalent, and if you simplify all those fractions, they're all 2/5. So we can conclude that triangle ABC is similar to triangle EDC. We showed the sides are proportional, so we used side, side, side similarity. And now that we've shown the triangles are similar, you can use this idea that if two triangles are similar, then corresponding angles are congruent. Specifically, I want to use it this way. I want to say, okay, well then angle D must be congruent to angle B. This is using that new idea. And if I know those two angles are congruent, we can see that AB and DE are parallel because of alternate interior angles. So that last idea would be parallel because if alternate interior angles are congruent, then we have parallel sides, parallel lines with it. Okay, next proof here, and we're going to make use of this means extremes product theorem we talked about in that first section, 8.1, to reach a little different conclusion, and it is this that you see there. But again, we're going to go about this first by proving that the triangles are similar. So let's mark our given information and set up our proof. Okay. And if we're trying to prove those two triangles congruent, we need some other information. We have our nice vertical angles there. So let's just call that 1 and 2. We can say angle 1 is congruent to angle 2, because if vertical angle is then congruent. Now we have enough to prove those two triangles similar using angle, angle. So let's say DEC is similar to triangle GEF. We're using angle, angle. Now we can set up a proportion. And I want to set up a certain proportion here based on what we want to conclude. I think it'll make more sense at the end. I want to say we can conclude that CD, that side, over FG has to equal side DE divided by EG. And again, this idea is this new one, which is that the corresponding sides of similar triangles have to be proportional. Finally, to get this proportion to give us the conclusion we want up there, we need to use the means extremes products theorem. So we need to conclude by this cross-multiplying idea that CD times EG equals DE times FG. And again, the reason here is the means / extremes product theorem. Okay, one more proof here. I want you to pause, set up your proof, mark the given information. Okay, so we're trying to get this proportion holds true. We're going to have to first prove similar triangles. If you're having trouble seeing which triangles to prove similar, here's a little piece of advice. Look at your proportion and kind of match it up on your picture. So, for instance, it says JM is going to be proportional here with HJ in the other triangle. So I'm going to mark JM and HJ in the same color. And then I'm going to jump down and say, okay, JM is going to match up with MK. So let me mark MK. And then I'll mark JK in that same color. So you can get a little bit of a better idea about which two triangles we're trying to prove congruent and how they're matching up. So if you look at it that way, our goal becomes to show that triangle, let's say we did JMK, is similar to, so if we did JMK, we'd have to do HJK for the larger triangle. Again, those are the triangles we want to prove similar so that we can end up showing that proportion. So at least that gives us an idea of kind of where we're going. We need some more information. Oops, sorry. First of all, if JM is an altitude, then we know JMK is a right angle, and we actually already marked that. So angle JMK is a right angle. And we can just say if altitude then forms right angles. Okay. Now we have HJK and JMK are both right angles, so we can conclude that they are congruent. A reason, if right angles, then congruent. Looking back at our picture, and again this is kind of a theme with similar triangles, we need something else. You can see that they have a shared angle. Specifically, angle K is an angle in both of those triangles. So we're going to need to come down here and use reflexive property to say that angle K is congruent to angle K by reflexive. And now we have two angles. We can use angle, angle, and we're in a position to prove exactly those two triangles similar that we wanted to earlier. So JMK is similar to triangle HJK, our reason being angle, angle, similarity, and we use steps 4 and 5. And then once we get those triangles similar, the reason we can set up that proportion is our new idea, which is, oops, should be a 7 there, which is corresponding sides of similar triangles are proportional. And that's that proportion we can prove there. Okay, the last problem here. I'd like you to go ahead and mark the given information on the picture, please. Okay? And we are trying to find PO, so let's throw down a variable there. And we want to set up a proportion, but in order to set up a proportion, we need to first show that these triangles are similar. Sorry about that. So the other thing we can mark in this picture is those vertical angles are congruent, and then we can conclude that we have two similar triangles using angle-angle similarity, and specifically we get that PMO, if we look at our diagram, is similar to triangle PSR. Now, using the idea that if we have similar triangles, then corresponding sides are proportional, we can set up a proportion such as this. So if we did PM over PS, that would be the same as PO over PR. Subbing in and solving that proportion, we get our missing side is 48/7. And that concludes 8.4 note.